The solution to a system of equations is typically a point. Unless those lines are parallel or they're the same line, we have a single point of intersection that is the solution to a system of equations. With a system of inequalities, the solution is going to be an entire shaded region, an entire collection of points that works in both of the inequalities, or all three inequalities, as we see in the third example. And so what we need to do is we need to graph the two inequalities on the same coordinate plane, and then figure out where those shaded regions, where those collections of points that work in the two respective inequalities overlap. So on this first one, we'll again graph by just treating it like a line to start off with. So I need a slope and y-intercept to be able to graph it. So the slope is -1, the y-intercept is 2. So I'm going to go up 2, and then from there I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, up 1, back 1 a few times. I'm not worried about a specific intersection point, like when I'm graphing a system of equations, because I'm looking for an entire region of the graph that's going to be my solution, but I should still try to graph as accurately as possible. Now for this first inequality, my line's going to be dotted instead of solid, because there's no equal to sign in my inequality. And then I just need to determine whether I'm going to shade above or below my line. I'm not actually going to do any shading yet because I don't want to dirty up my diagram, but I need to know where I'm supposed to shade. So I can do that by either plugging in the point 0, 0, or we can use the other rule that says that if it's y on the left-hand side of the inequality, then I can look at the inequality symbol, and since it's less than on this one, I'm going to shade below the line. So I'm going to make a note for myself that I'm supposed to shade underneath this line here, but I'm not going to do that yet because I still need to graph this other inequality. And so for this one, we have a slope of 2 and a y-intercept of 4. So I'm going to go up to 4, and then I'm going to go up 2 over 1, up 2 over 1, down 2, back 1 a few times. And so again, I'm going to have a dotted line because there's no equal to, so the points on the line do not work in my inequality. And again on this one, I have a less than symbol, which means I'm going to be shading below this line as well, which means I'm going to be shading underneath the line here. Again, I could have used 0, 0 as my test point, but instead I'm going to use that shortcut. And so now I essentially have 4 regions. We can start counting them. 1, 2, 3, or 4 as the place that could be the solution to this system of equations. And so in this case, the red line, I'm supposed to shade below it. For the purple line, I'm supposed to shade below that one. And so the place where these two shaded regions are overlapping is going to be here in region 4. The points in region 2 don't work in either of the inequalities because they're not below either of the two lines. The points over here work in the red inequality, but not the purple. The points here in region 3 work in the purple, but not the red. It's only the points that are in region 4 that are solutions to this system of inequalities. In our next example, we're not looking for a double overlapping shaded region, but instead it's going to need to be a triple overlapping shaded region because we've got 3 inequalities in this example. Now, the bottom 2 inequalities should be pretty easy for us to graph. So if we think of them as x equals -1 for the purposes of graphing the boundary line and y equals 2, those are just going to be vertical and horizontal lines respectively. So I'm going to go to -1 and I'm going to put in a vertical dotted line to represent that x equals -1. Now it says x is greater than -1. Well, the x's that are greater than -1 are going to be to the right of that line. So I'm just going to make a notation to indicate that I'm supposed to shade over there. In the case of y is less than or equal to 2, so for that one, we'll do that in green. So that's going to be a horizontal line through 2. Because of the equal to, we're going to have a solid line. So I'm going to have a solid horizontal line here. And for the y values that are less than or equal to 2, that's going to be below this line. So far, if it was just those 2 inequalities, it would be this region here that would be shaded. Everything below the green line and to the right of the blue line. But we clearly have one more inequality that we have to consider, and that's this one here. Now x squared plus y squared equals 49 if we ignore the inequality for now. Hopefully we recognize that as being the equation of a circle whose center is at the origin and with a radius of the square root of the number over there, so a radius of 7. So I'm going to go over 7 in each direction, here, 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 and here. And my line, my circle is going to be solid because I have the equal to. So I'm going to sketch in a solid circle here. We'll pretend like that's solid there. And now I have to determine where I'm supposed to shade. Now this might be a case where it might make sense for us to plug in a point like 0, 0 to check to see if it works or not. But we can also use our rule in this case, less than or equal to. I'm going to be shading inside of the circle. For a greater than or equal to, in this case, I'd be shading on the outside. But if I plug in the point 0, 0, 0 squared plus 0 squared is less than or equal to 49, that's definitely true. So that means 0, 0, the point inside the circle, is a part of our solution region. And so then, if I'm inside the circle, below the green line, and to the right of the blue line, that means that my solution region is all the points that are inside of the circle over here. So any of those points that are in that region are solutions of all 3 inequalities, and so therefore solutions to the system of inequalities.